Good morning everyone. This is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So today I want to discuss about engineering typology subject. So in this subject, what is the importance of typology for engineering branches and as well as other disciplinary. So why should we learn the typology? The course code is AMEC 24. So in this first module is surface interaction and friction. So in this module, the topics are framed like this. The first topic is topography of surfaces. So in this topic, we will learn, what do you mean by topography of surfaces? So how many types of surfaces are there? And the second one is surface features. So in this, how many types of surfaces are there and what is the importance of surface in typology? What its features we will learn. So similarly, and the properties and measurement. So what is the properties of this typology and how do you measure the wear and the friction, the measurement techniques we will study. Similarly, surface interaction and then adhesive theory of sliding friction and rolling friction. Again, here the friction is classified into two types. One is rolling friction, another one is sliding friction. So detailed classification and detailed description about these two frictions, we will learn the friction topic. The friction properties of metallic and non-metallic materials. What are the properties of friction properties of metallic and non-metallic materials? And then friction in extreme conditions and thermal concentrations in sliding contact. So all these topics we will learn under this module 1, the surface interaction and friction. So now we will see one by one from starting onwards. So first I want to give small introduction about this the typology subject. So typology is a subject study of friction, wear and then lubrication. So this subject covers these three topics: the friction, wear and lubrication. And this this subject, the typology word came from the Greek word. So that is tribos. So it means rubbing. So the rubbing of one part on another part. So the contact between two surfaces. It may be smoothly rubbing or roughly rubbing. That is depends upon the surface. So that's why we should learn what is the importance of surfaces in a tribology subject and how many types of surfaces are there? We will see later on coming topics. So the term tribology was formed in 1966 and it is defined as the science and technology of interacting surfaces in relative motion. So whenever the two surfaces are interacting in relative motion, then the friction will be generated and wear also there and some lubrication also required. So that's why the tribology, the subject that covers these three topics, and the tribology covers the basic engineering subjects. So what are the basic engineering subjects? The solid mechanics and fluid mechanics and material science and lubrication chemistry. So all these subject covers this tribology. So particularly while designing of mechanical components, so that is machine components, the tribology is plays important role. Why? Because the continuously in mechanical the components are rubbing. So rubbing and contact one among. So that's why the friction always will be generated. To reduce the friction, lubrication also required. So all these topics we will study these the lubrication properties and the friction types we will see in the next the coming up slides. But mechanical components always undergone this friction and wear. So that's why the tribology is heart had their functions. When the gear function and the bearing function, so the tribology is a very, very important plays important role. So that's why we should learn the tribology concepts. See, in this the diagram, they are creating fire by using sticks. How they are creating? This is very old process. In ancient times, on the order of about 5 lakh BC, the early humans learned that by rubbing sticks together with great force, they could create fire. By applying force, they are rubbing sticks. So due to the friction property, the fire will create. They don't know this property is the friction, but the time they want some fire for cooking purpose. So that's why they are using sticks and rubbing together and the wonder created. Similarly, see in this picture, the rolling motion is required less effort than sliding. So what is this? So what do you mean by rolling motion and sliding? So already I told you in starting, the friction is two types. One is rolling, another one is sliding. Rolling friction and sliding friction. Which one is better? When compared to the sliding, the less friction will be generated in rolling. But sliding, the friction will generate and more effort also required to pull the vehicle or any object. So that's why at that time the wheel was invented around 3500 BC. So first they are using sliding. So instead of sliding, they created wheel. So why? Because in the rolling, less effort is required. It moves freely. So next one is tribology is a multidisciplinary subject, not only for particular branch, not only for this mechanical subject. Everywhere tribology is required. The tribology properties are important in multidisciplinary subjects. What are they? The multidisciplinary subjects are here material science, environment, the life cycle assessment, and the nanotechnology, and lubrication chemistry, the turbo chemistry, biomechanics, and then friction, molecules, machine design, and machine elements. So already I told you the solid mechanics and fluid power systems and fluid mechanics. It is a study of friction. One is friction and the wear properties, and then lubrication. Which type of lubrication is required? So what is the lubrication mechanism while in motion, relative motion? Example, bearings and gear transmission systems in mechanical engineering. And then the structure is important, the structure of the material in material science. So how the molecules are arranged, and then wear. So the wear is purely depends upon the surface, the material surface, and then material properties. So all materials having different properties, the mechanical properties, electromagnetic properties, chemical properties. So that's why this subject, tribology, is a multidisciplinary subject and covers all these subjects, all these topics. See, already I told you the tribology is everywhere, not only in mechanical engineering, not only in chemical engineering, so not only in other branches, electrical engineering. So that's why you can say the tribology is everywhere. Example, the tire rolling on road. High friction is required. Example here shown. For tire, material and a road, there is a friction. So how much friction required? High friction or low friction or medium friction? So due to the friction property, so there is the possible of grip between tire and the road. If less friction is there, suppose there is no friction, the slipping chances are very high when the friction is very less between the tire and road. So tire is one surface and the road is another surface. So that these two surfaces, whenever interacting, contacting one among other, then friction automatically will generate. So we can create wonders by using this friction. Sometimes advantages also there and disadvantages also there. And then the second one is bearings. In this case of bearings, low friction required and wear required. Low friction and low wear required. So suppose high friction and high wear is there in the case of bearings, there is no use of bearings. The type of bearings will fail. So in the case of mechanical components, the mechanical engineering, so if you want to design any bearings, you should concentrate on friction property and wear properties. If you want to minimize, then only your bearing design, the bearing design will be a success. Otherwise, the bearings, the failure will be occur. The bearings are again classified into here ball bearings and roller bearings. Ball bearings and roller bearings. Two bearings are there. So while designing these two bearings, the tribology concepts are very, very important. So next example, joints. Second here, I want to explain about this the joints. Joints are again classified into two types. One is temporary joint, another one is permanent type joints. So the permanent type joints are fixed together. So example, welding. Two plates are welded together with the help of weld material. So if you want to dismantle or if you want to replace one plate, you can't remove. Why? Because that is permanent type of joint. So if you want to replace, so completely you have to destroy the joint. Whereas in temporary joints, like here nut and bolt, you can replace, you can remove, you can dismantle. Whenever you want to dismantle the assembly, you can easily dismantle the assembly. In this, the low friction is required and no wear in contact. There is no wear in contact. So the nut will contact the threads, contact on these bolt nuts, bolt threads. This is one type of joint. These type of joints are called as temporary joints. Couplings, another example for temporary joint. And the permanent type joints, the riveted joints, example, riveted joints also permanent type joints. But in this case, so what is the importance of tribology in joints? While using this nut and bolt, the low friction is required. And no wear in contact. Suppose a high wear is there, so the in contact, so the more lubrication required and high friction will be generated. So ultimately, after some time, the bolt or nut will be failure condition. Again, you have to replace the new bolts. So, example, the machine, the mechanical machine, they're having a lot of components. Suppose example, take a lathe machine, having a lot of components, nuts, bolts, screws, bearings, tool carriage, lever, lead screw. So like this, you have to assemble all these. First, you have to design, and then all these components you have to assemble. for the better work. If proper lubrication is not used, the proper material is not used without considering tribology properties. Suppose you want to design any mechanical component, you design a component without taking any considerations of tribology properties. So while running condition, while it is in a relative motion, the component 100% will fail. So that's why in before designing, you should concentrate on this material properties. Next example, snow. So in this, the low friction is required for gliding, but high in the grip zone. The high grip is required here. So here, suppose if a high grip is not there, there is a chances of slipping. And a low friction. At the same time, the low friction for gliding purpose required. So next example, shoe and floor. So medium friction for easy walking and dancing. Daily we are walking on road on a floor with the shoe. So there is the friction between this shoe and this surface. So how much friction required here? So not required high friction and not required a low friction. So only the medium friction. So then only you can walk very easily on a floor. While doing dancing, suppose while doing playing, so then the medium friction is required. And then next example is brake disc. This one also mechanical component. So controlled stable friction is required, not too low or not too high. Very stable friction. So like the medium friction. So while using this disc brakes, so this type of brakes we are using for the vehicles. The friction is required, and the stopping and the starting of the engine. So you want to stop the vehicle while running. So the brake is required. How it will function? With the help of friction property. So without friction, we can't stop the vehicle. So here we are using one medium, that is brake, the brake surface. So that's why. So which type of surface is required for this the brake material? So you have to study the surfaces, types of surfaces. Next, cam and follower. So the cam and followers are used in engines for valve opening and closing. This type of mechanism is required in IC engines. So in this, in between the cam and follower, there is a contact between these two. The cam and follower, the contact, the type of contact is here, the point contact. There is no wear and low friction. So by using this mechanism in engines, so the valve opening and closing will be occur. Next, piston ring cylinder. This is piston and these are rings, piston rings. So there is a friction between this, while moving this piston inside the cylinder, the rubbing action will occur between the cylinder and this piston surface. So on this surface, the piston surface, the rings are mounted. Again, these rings are classified into two types. One is piston, one is oil rings and compression rings. So detailed explanation is not required for this stage. We are concentrating on wear property and friction property, and then third one is lubrication property. So that's why the tribology subject is revolve around these three topics: friction, wear, and lubrication. While designing piston rings, you should concentrate this property, the wear properties and friction properties. And same time the lubrication also required while moving. It moves from top dead center to bottom dead center. Again bottom dead center to top dead center, where it is in motion. We will study in four-stroke engine working. So that's why for this arrangement there is no wear and friction is required, that low friction. If not required high friction. If it is suppose in piston and while rubbing, while it relative motion, the high friction is suppose occurred, what will happen? The friction, the piston rings will damage. After some time, what will happen? The piston will jam in the cylinder. There is further movement in the cylinder. See, if suppose the piston movement is not there in cylinder, there is no power. There is no power stroke. There is no output. The engine will not move forward. Clear? So that's why the friction property is here also required while designing the piston and piston rings. Next example, in our daily routine life, we are using the chalk and board while teaching lessons. We are using chalk and chalk on a board. So controlled here wear process. So some friction is there and a wear also there, but here controlled wear, not too much wear. That is the controllable. So easily we can manage that wear. So due to the wear property, what will happen here? So while writing on a board, the chalk, the material is scoring. So after some time, what will happen? The material, the chalk destroyed in the form of powder. Similarly, pen and paper, the controlled wear process. We can control this type of wear, but in an engine's case and ball bearings or rolling bearings or piston and other cams and followers, we can't control the wear process. If you are not using proper material, you are not using proper lubrication, you are not designed with proper surfaces, so the wear must be possible. To control the wear, we will use the lubricants. So this is pen and paper controlled wear process. Next one is artificial joints. So already you know. So nowadays the doctors are changing these joints. So before changing like this, and after changing, the artificial joint is like this. So there is the grid is required. In this case, the surface, the material, and this material and body material. So here also joints, the wear process is there. So suppose the wear is very high in joints, then this type of artificial joint replacement is required. Next, now we will discuss about tribo system. So in this tribo system, there are 4 elements. One is element 1 and element 2. Element 1 and element 2. These two are contacting one each other. So there is a tribo element 3 interfacial medium is there. This one. When it is sliding or rubbing, then tribo element will act the surrounding environment. That is 4. The surrounding environment is temperature, moisture condition. Yeah, tribo element 1 and element 2 and element 3. It is the medium. The interfacial medium is like a lubricant. This is said to be the tribo system. So now considering the complexity of the tribological system, it may be related to point out that friction and wear characteristics of materials are not their intrinsic or inherent properties, but are highly system dependent. So intrinsic properties are inherent properties, not the intrinsic and extrinsic properties. The intrinsic properties like boiling point and melting point of the material, density, and then extrinsic properties are mass and volume. The wear characteristics of materials are not their these intrinsic properties. So coming to the friction topic, so we meeting friction in all aspects of everyday life. So by walking, moving, dancing, and stopping or turning a car. So walking, everyday friction appear, and then moving, stopping or turning a car. Suppose you want to stop a car while moving a car on a road. So with the help of a friction property, already I told you, that is that component is called as brake. Turning, if you want to turn a car, so by using steering mechanism, you can easily turn a car. So the steering mechanism, there is a bearings and a lubrication. So it works, the steering mechanism works on a friction and this lubrication. The Egyptian pyramids and tombs are the invention of wheel. It leads to invention of wheel. Why? Because the major cause of energy dissipation and frictional heat generation and temperature rise. Suppose here one block is there. You are applying force on this block on this block horizontally. That is tangential force. So always the one force will act perpendicular to this tangential force. That is normal force. And one important force is there between these two blocks, that is friction, frictional force. So the friction Frictional force is nothing but resistance to the motion. So opposite, suppose you are moving like this, you are pulling this object like this. So in another direction, opposite direction, the friction force will act. So that's why the frictional force always directly proportional to normal force. So we can write F is equal to mu. So mu is a coefficient of friction. So how much friction is there between these two surfaces? Multiply with this normal force, we will get the frictional force. It is the another name is resisting force. So the frictional force resists the tangential force. If there is no friction between these two blocks, so you can easily move this object. So the less support is required. There is no friction, so there is no question of support here. This object freely moves on this surface. So next examples of occurrence of sliding friction. Rolling friction is there and sliding friction. So the examples for sliding friction, take a machine tool sideways. Examples for this sliding. So these slides one another. So here the sliding plates are there in the machine tool. The sideways are required for this mission. So that's why here the sliding friction property is very important. So here also the clutch and engine bearings, the clutch movement, clutch plates, the friction between one plate and another. Occurrence of sliding friction here, ball bearings, wheel on rail, and gear transmission. So here the wheel on rail is sliding, and at the same side the sliding motion, and then rolling motion also there. Here ball bearings rolling, and due to this rolling, the balls are moved slides like this. So these balls are arranged in a case. Next one is the friction is affected by the following points. So what are they? We will see. The first one is the presence of wear particles and externally introduced particles at the sliding interface. Suppose two components are contact. The two component surfaces are in a sliding motion. So there is a presence of wear particles in between this sliding. Suppose two sideways are like this moving, sliding. So in between these, suppose some wear particles are present. What will happen? The friction will be generated. So due to this friction, some material will damage. You have to replace this sideways. Similarly, the second, relative hardness of the materials in contact. Relative hardness of the materials. So this material hardness and this material hardness is different. They are in contact. Then possible of friction. Externally applied load and displacement. the externally applied. So suppose you are applying load on this object. Now how much display? So the displacement amount and the applied load is important in this friction. So the applied load is very more. There is no displacement. So then the possible of friction is very high. So similarly, environmental conditions such as temperature and lubricants. So what is the environmental conditions? That is in turbo systems element 4. So environmental conditions are very important. The temperatures like temperature, lubricant. Surface topography. So what is the nature of surface? What is the structure of this surface is a very important topography topic. So we will detail this explanation I will give in the surface topography topic. Microstructure or morphology of materials and apparent contact area. So what is the contact area between these two? Suppose here the contact area is the surface contact. Suppose in this case or two wheels are contacting like this. So then there is a point contact between these two. So that is what is the area of this contact. The friction is depends upon this area of contact. Suppose surface is there block. So I apply load like this. This is normal force and here tangential force. So next one is kinematics of the surfaces in contact. That is the direction and the magnitude of the relative motion between the surfaces. So the kinematics of the surfaces so means that the direction, in which direction you are applying load and what is the magnitude of load and then the relative motion between these two surfaces. So that will leads to the friction. So that's why the friction is affected while in relative motion between two surfaces. So that's why the surface topography plays an important role in determining the performance of various tribological mission components. Suppose you want to determine the wear properties of a particular material, wear characteristics. If you don't know the surface the topography, you can't calculate, you can't analysis. So that's why the type of surface photography plays an important role while determining the performance of various tribological mission components. So there is a need to establish a correlation between the surface topography and tribological performance in order to establish optimal surface topography. So first you establish a relation between these two, compare and validate the tribological performance and surface topography for different moving mission components. So then only you can find the optimum surface for topography for particular application for particular moving mission components. So now we'll discuss about the surfaces. What do you mean by surface here? The surface is made by sudden termination of the bulk structure. Here you can see in this, the bulk structure is there. It requires energy to terminate the bonding. So already you have studied in material science. So the surface is energetically less stable than the bulk. So here one molecule is there a surface and another surface. So suppose you want to terminate this structure, then the lot of energy is required. Okay, stable than the bulk energy. So this bonding was involved. The bulk lattice for a solid. This is the solid one. The liquid is able to produce the interface. So this type of energy is called as surface free energy to terminate the bulk structure. In the case of liquid interfaces, this energy is called surface tension. So surface free energy is known as in the case of solid interfaces, and in the case of surface tension, in the case of liquid, it is called as surface tension. So why surface is required? So without surface, you can't transfer the force from one surface to the another surface. You can't apply. You can't use the application without another surface. Suppose you want to write a topic on the blackboard. So you want one surface, that is pen and paper. Similarly, chalk and board. So have the surfaces have major impact on several areas, including semiconductors, corrosion, detergent, and tribology systems. And then the specialized techniques are required to study topography, composition, and chemistry of surfaces. So in this slide, show nature of solid surfaces. The solid surface nature is one is base material here, and then lightly deformed layer, that is the layer size is 1 to 10 micrometer, and then a heavily deformed layer and built by layer, so that is nothing but melted during machining, and chemically reacted layer, the size also mentioned here 10 to 100 nanometer, and here PC sorbed layer and a chemi sorbed layer 0.3 nanometer. So the PC sorbed layer is nothing but it is a very thickness, having high thickness and very strong. It can withstand this layer for environmental conditions like temperatures and lubricants, high temperatures. So these type of layers are called fizzy-sorbed layers. So the chemi-sorbed layers, so having the metallic bond, different structures involved in this layer. So next one is significance of surfaces in tribology. What are the major significance of surfaces in tribology? Shown in this diagram. So this surface created in hinges, the friction, wear, and effectiveness of lubricants, and then surface defects and initiation of cracks. So if any defects are there, and what is the initiation of crack, and the thermal and electrical conductivities. So these are the most significance of surfaces. And then the surface defects caused during manufacturing. So when it's manufacturing, suppose a mission component is there. While manufacturing, a lot of defects are there. So the defects will be occurred due to this crack, internally or external crack, craters, and so the craters nothing but like small holes, faults, seams or labs, and heat affected zone. So all these defects you can't see directly. By using some examination methods, you can detect this defect. So and then interangular attack, metallurgical transformations like temperature, pressure, cyclic transformations, temperature, press and cycling, plastic deformation bond tools, inclusions, residual stresses and splatter. So all these surface defects. Some defects internally occur and some defects externally. So in external defect is there on surface, you can detect very easily by seeing. There is no need of separate testing. For detecting these surface defects, there is a method, destructive methods, non-destructive methods and destructive methods. But by using different methods, you can determine. So all these defects occur while it is in manufacturing. So due to the poor quality of material, the poor operation, or not using proper guides, not using proper machining tools. The surface characterization is possible by using the general features of surface and the chemistry of surface and the mechanical properties. So by changing the surface, by changing the features of surface, by changing the mechanical properties of the materials, you can enhance the material for better efficiency. So the surface characterization, you can create the best optimal surface for our desired application. So the general features of the surface appearance and shape of the surface. So what is the shape of the surface? It may be rectangular, it may be circular, it may be square. The appearance, the color, and then elements presence. Which type of elements are there in material and surface? The chemistry, the phase distribution, and then mechanical properties. Mechanical lot of properties are there. Hardness, creep, and then fatigue, and modulus yield strength, toughness, malleability, stresses and strains. So all these properties are called mechanical properties. The most surfaces are depends upon these mechanical properties. So while designing a mechanical component, you should concentrate on these properties. So what is the property of the material? Which type of property is required for particular application? So brittleness and ductility. So ductility property is used for steel and mild steel. Brittleness property, cast iron. When it is required, brittleness. When it is required, ductility. Clear. So the surface characterization will be possible by changing all these properties. So the origin of the surface irregularities, one is, so what is the base, what is the cause for surface irregularities? When it is in manufacturing, the production process, turning, grinding, polishing. While it is machining, when it is grinding, the polishing, some irregularities will be occur. So that is the base starting point, the origin of the surface irregularities. And then the material structure, so brittleness, and then atomic structure, which type of structure is there, atomic structure, and then use of the surfaces, that in wear condition, running in, corrosion. So all these process are leads to cause of surface irregularities. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.